Hello everyone, I welcome you all to JK Tech Solution YouTube channel. Today in our video we are going to discuss about Coulomb's law using Matlab. So let's start our session. So first we need to understand what is mimic Coulomb's law. As we all know, Coulomb's law is nothing but electrostatic force between the two charges which are separated by the distance r. So that is what given in the given image. Let us consider charge q1 and q2 which are separated by a distance r. So for that the Coulomb's law formula is F equal to k into q1 q2 divided by r square, where k value is 1 by 4 pi epsilon naught and q1 q2 are the particle charges and r is the distance and k is also a Coulomb's constant. This is what the formula in normal form. In vector form we can say it as f12 vector is equal to 1 by 4 pi epsilon naught q1 q2 divided by r12 square into r12 cap. So this is what the formula for vector form. So we have seen both normal and vector form formula in Coulomb's law. So let us see one example. So let us consider a charge q1 equal to minus 20 microcoulomb is at point minus 6 comma 4 comma 6, and then a charge q2 equal to minus 50 microcoulomb is located at r 5 comma 8 comma minus 2 in a free space. So they are asking us to find the force exerted on q2 by q1 in vector form. So the distance were all given in meters, so we need to verify the answer using Matlab. So let us start our solution. So step 1 is we just writing the given. So q1 equal to minus 20 microcoulomb. So micro is nothing but 10 power minus 6. So minus 20 into 10 power minus 6 coulomb. The point P is equal to minus 6 comma 4 comma 6. We are considering the point P as R1 vector. And then the R is equal to 5 comma 8 comma minus 2. We are considering as R2 vector. And Q2 equal to minus 50 microcoulomb, which is equal to minus 15 10 power minus 6 coulomb. So in the step 1 we are writing the given parameters. The step 2 we are calculating R12 vector. So as you all know, R12 vector equal to R2 minus R1. So we just substituting the given values in the R12 vector equal to R2 minus 1. After substituting this, we are getting 11ax plus 4ay minus 8az as R12 vector. So next we are finding R12 square. So R12 square we are getting it as 11. So we are finding the magnitude. So after finding the magnitude, we are just putting the square root. So after putting square root, we are getting R12 vector equal to 14.1714. So this is what the R12 vector we have received. The step 3, we are applying the Coulomb's law. So after applying Coulomb's law, F equal to k q1 q2 by R12 square. Then we are just applying the formula. So after applying the formula, we need it in this normal form, we need it in vector form. So that only I have used AR cap. So AR cap equal to AR vector by modulus of AR vector. So after applying this, we are getting 0.0315 11ax plus 4ay minus 8az vector. So finally, we are getting the force as 0.03465ax plus 0.0126ay minus 0.0252 az vector. So this is what we need to verify this answer in Matlab. So this is what our question. So next we are going to, first we need to create a Matlab account. So for creating a Matlab account, you need to visit www.mathworks.com. So I'm just clicking this link, www.mathworks.com. It's loading now. After getting the link, mathworks.com. So you need to click the button sign in. Okay. First you need to click the button sign in. After sign in, you will be asked if you are already created account, then you can enter the mail in sign in. Otherwise you need to create a new account. Now we are going to create a new account. So I'm going to give create account. So after giving create account, we need to enter the email ID. So I'm just entering my email ID. First I have entered my email ID. So after entering the email ID, once I will check it. One antenna design at gmail.com. Okay. So after entering email, you need to give next. If the error occurs, you just need to So after giving your email ID, you just need to give next. After giving the next, it will ask you to access your organization license. Make sure to use your work or university email. So you can you either use your university college mail, otherwise you can personal mail. Anyway, I can give continue anyway. So it is verifying right now. So after that, you need to create a password. So your password should contain both uppercase and lowercase letters. So after entering password, you just need to give next. So after giving next, MathWorks will send you a verification email. So I need to check in your mail. So I have received a mail with the code 099528. So you need to enter this code, the box, and then give I accept the online services agreement. Then next. After this, it will ask your first name, last name. So you need to enter your first name and last name. Okay. So after entering your first name and last name, you need to enter your nation, location, and then you are a student, teacher, or engineer, whatever your role, you need to enter it, and then your department. After entering your department, your role. After entering, are you at least 13 years or older? So up to your age, you can give it. So then just give next. After giving next, it will ask you your university location, right? So I am giving my school and university. So after giving your information, you need to give next. So it is creating a MathWorks account. So after creating a MathWorks account, you can just check your profile. So you need to click Matlab. So after clicking Matlab, you can click on use Matlab online basic. Use online up to 20 hours every month. So use now for free. Okay, now you just need to click this. So it's loading right now. It will take some seconds. Okay, it's successfully loaded right now. So here only we are going to type our code. So here is a command window. You need to create new script window. We need to type our code. So just need to click on new script. So after clicking new script, a new document is created. So here only we need to type our code. So we can just look after our question. So here we are looking back our question. A charge given. So this is what our given. Okay. So from this given only we need to answer the question. The charge Q1 equal to minus 20 microcoulomb. So first of all, we need to give the input to the Matlab code. So first I can give the input. So first of all, I'm going to give Q1. Okay. So first Q1. Q1 is equal to, you can either use caps or small, there is no issue. So Q1 is equal to 20. The question they have given 20 microcoulomb, that is 10 power minus 6. So for indicating 10 power minus 6 in Matlab, we can give it as E minus 6. Okay, so it is 10 power minus 6. So we have given the Q1 equal to 20 E minus 6. Okay, so first of all, we given the input. For Q1 input, we have given. Next, we need to give the Q2. So in the question, they have given Q2 is equal to minus 50 microcoulomb. Similarly, Q2 equal to sorry, in the first case we did not enter minus, so we need to enter minus. Okay, minus 20 e power minus 6. Okay, and then in the Q2 they have given it as minus 50 microcoulomb. Okay, so minus 50 e power minus 6. Okay, then next they have given R1. Okay, so R1 equal to, they have given R1 value as minus 646. Okay, minus 6 space 4 6. So we are representing 3D. Then R2. Okay, so then R2 equal to in R2 they have given, we have assumed 5, 8 minus 2. So we are just substituting 5, 8 and then minus 2. So after entering it, we have substituted Q1, Q2, then R1, R2. From the given question, we have substituted these 4 values in the Matlab code. Now we need to find. Okay, so now we need to find. Now we need to find R2 minus R1. Okay, so R2 minus R1. So for that, for finding R2 minus R1, we can use let us assume the variable a equal to no or norm. For finding magnitude, we are using norm. Okay, norm of R2 minus R1. Okay, so for we are finding it in magnitude, so I am using the word norm. Okay, no or m. So normalization of R2 minus R1. So after giving it, so just adjust. Okay, so we have given the value of a, right? So after giving the a value, we need to find a unit vector. So for finding unit vector, I'm just using the keyword unit. So unit equal to R2 minus R1 divided by a. So I given the a value, so magnitude value. Okay, so unit vector equal to R2 minus R1 divided by a. Okay, so we have calculated a unit vector. Then after calculating the unit vector, we are finding the square of the unit vector. Okay, sorry, square of the magnitude. Okay, so b equal to a. For adding the square, we need to put exponential symbol. So a power, so a power a square. Okay, so I added the a square. So now we are applying for Coulomb's law. Okay, so our third step. Okay, second step, first step we have completed. Second step also we have completed. The third step we are applying the Coulomb's law. Okay, so Coulomb's law, we know F formula F equal to 1 by 4 pi epsilon naught Q1 Q2 R12 square into R12 cap. So we are just simply substituting this formula in the Matlab code. Okay, so we are just substituting F equal to Q1 star multiplication Q2. Okay, Q1 multiplication Q2 divided by as we all know 1 by 4 pi epsilon naught. Okay, 4 star multiplication 3.14. Okay, 1 by 4 pi value, as we all know pi value is 3.14. 1 by 3.14 into, we as we all know epsilon naught value is 8.854 into 10 power minus 12. So I am just substituting 8.854 into 10 power of, sorry, not into 8.854 e minus 12. Okay, 8.854 e minus 12. Okay, so as we all know, we have a unit vector here. There is R12 cap. So we need to add this also in our code. Okay, so then we have, so we have R square. Okay, so we have in the formula R12 square. So in the place of R12 square, we are adding b. So we have taken b as a square. So we need to add b star b. Okay, so we are in the denominator part, we have completed all. Next, we need to substitute the R12 cap. Okay, so as we all know, we have already found the R12 cap. So R12 cap is nothing but the unit. Okay, so star unit. Okay, so we are just substituting the R12 cap. Okay, you can either give in the back or front. There is no issue for unit. Okay, so star unit. So I have given this. The next we need to find the normal that is nothing but magnitude. Okay, so then f capital F, I'm taking capital F equal to n over normalization of f. Okay, so I have given this f equal to normalization of f. So after giving this code, we need to just save our file. Okay, either you can save, just you can give save control s. So I'm giving it as file 1. Okay, so I'm just saving it. So after saving it, you can run this code by clicking this run section. So after clicking run section, you will be getting the values here. Okay, so as you can see, so as we have verified the values here. Okay, so as you can see here, So here we have received a value. Okay, I can show you the results in a clear way. Okay. So here we have given the input as Q1. Okay, in the command window, we'll be getting the output Q1 equal to -2 into 10 power -6, then -5, then R1, R2, A value, then unit vector value also we have received, and then B value, and then F value. So here only we have calculated the magnitude of F vector. You can verify it. So here F equal to 0.03465x plus 0.0126ay minus 0.0252 AZ vector. So same value we have received in Matlab 0.0347, 0.0126, and then minus 0.0252. So finally we have verified the answer. So the normalization value we have given 0.0447. That too we have received within normalization of F vector. Okay, that is magnitude of F vector. So this is what we have verified the answers using Matlab. So I think you have understood this video very well. So next, if you want the reference code, okay, you can, for Matlab account creation, you can use www.mathworks.com. So if you want to refer this code again, so you can refer the website that is www.antennacalculator.blogspot.com. Okay, so if you just click this link, you will be able to get the reference code. Okay, whatever we have typed the reference code, you can able to get that reference code in the Google. Okay, so I'm just clicking it. So in this calculator for design analysis of Coulomb's law using Matlab, you just need to click the first link, Coulomb's law using Matlab. So you can see our code. Okay, so I have mentioned this both MathWorks and then Antenna calculator link, the description box as well as in the comment section. You can refer it. Okay, so this is what our session. So thank you for patiently listening to our video for so much time. Thank you. I hope you to see you in next video. Thank you.